Now for the filters, the purpose of any filter is to reduce or remove impurities or contaminants in the air stream to an acceptable predetermined level. Naman sa masisiro. Pre-filters are generally used before air enters a dryer to remove various contaminants that might foul the unit. These filters are usually of the coalescent type so as to remove particulates and vapors, such as oil, hydrocarbons, and water. When combined with separators at this point, these filters may be called separator filters. So wala pa tayong subject na only filtration of topic, di ba? General because sa chemical to, hindi nata. Ang concentration sa filtration. So check na lang yung mga internet under discussion, types of filters. After filters are generally used after the drying process, the dryer, to remove smaller particulates than a pre-filter removes. Some dryers produce a very small diameter dust lines that must be removed from the ST. These filters remove particulate only. Point of use filters are generally used immediately prior to any tool or individual piece of equipment that requires additional removal of particulates to a greater extent than an after filter. So, doon ang final mo. So, oil removal filters are special filters used only to remove an unwanted amount of oil aerosols too small to be removed by coalescing. Activated carbon filters are used to remove gaseous oil and other hydrocarbon as well as small particulates too small to be removed by coalescing. Yung mga filters na kinakabot sa piping. Nakabit. Walang water filtration. Okay. Filter selection. Just as the degree of contamination in compressed air varies, so do the requirements for purity of the system at various points of use. This requirement must be established prior to the selection of filters in the system. Para alam mo yung pipiliin ng filter. Filters should be selected by their ability to meet established design criteria. Yung mga requirements na yan yung magiging design criteria mo. The manufacturer who is the most knowledgeable about the specific condition should be consulted as part of the selection process. So the following items should be considered. Number 1, the maximum flow rate expected. Number 2, desired pressure drop across filter. Number 3, temperature of airstream. Number 4, contaminants to be removed. Requirement for filter type and housing material. B, pressure rating as per stamp requirement. 6, drain trap requirement, automatic type preferable. 7, sampling port requirement. 8, filter efficiency. Filter selection procedure. Number 1, calculate the expected maximum flow rate of air. This figure should be expressed in the manufacturer's ratings unit, usually in ACFM or free air, standard cubic feet per minute. Number 2, determine the highest and lowest pressure that the filter can be expected to operate with during the operation. This pressure must be used in conjunction with the pressure drop in other system equipment. Kasi kailangan mo yun para makuha mo yung pressure drop sa filter. Number 3, based on the filter position in the system, determine what the contaminant or contaminants to be removed will be. Number 4, determine the maximum pressure drop across the filter. Manufacturers often use such as weighted pressure drop and dry pressure drop that do not take into consideration dirty element. Average condition use a range of between 6 to 10 PSI pressure drop. 5, will monitoring of the filter element for replacement be required such as color change or pressure drop? Kasi mga filter meron siyang dari dial, dari ruleta, may mga color code. Okay. So 5, 6, select the appropriate filter from a manufacturer's catalog. So ito yung mga filtration guides and application guides. Catalog to, di ba? So element grade, AA, yan, ating model na purpose. Extra cost policy, general purpose, high efficiency, and then particle removal, down to kung saan yung particle size mo. Yan. Efficiency, andito at 20.5 microns yan. Ano siya, may kapatid siya laging micron rating efficiency. Yung size siya ng particle. Maximum oil carryover. Maximum inlet temperature, 225. Tumaas ka, hindi na pwede. Clean dry pressure drops. Ito, 0.4, 0.5. So, pwede mo gamitin ito sa pressure drop. Color code, black. Yan. Flow direction, in, out, in, out. Ito naman, out, in, out, in. Ito naman ito. Ito yung flow direction. In, contaminated air in. Then, lalabas doon. Contaminate may iwan. Then, lalabas doon, clean air, free air out. Out, in, particulate. Ito naman, dirty air in, then clean air out. So, ito yung mga micron size. Halimbawa, ito yung buhok mo. So, yan yung mga size na sabi 1 micron. Mas maliit. Pinakamaliit mo. So, dito, policing, inside, inlet niya nagbaba. So, dito, dito na nagbaba sa kabilang side sa articulate. Application guide. Typical uses, ito, instrument air, blanketing, padding, nitrogen replacement, pipeline forging. So ito yung mga filter drive installation, compressor, after cooler, separator, filter grade C. Ito mga parang guide to guide. Guidelines to heating, heatless, regenerative, dryer. Discuss natin yan later. So dito, meron kang filter grade, RBORD, and dryer dew point, negative 40 Fahrenheit, negative 40 Fahrenheit. Yan. Part of the selection is yung dew point sa dryer. Next is pneumatic hand tools, robotics machine tools, spray painting, HVAC temperature control, so pneumatic control, di ba? So compress, ayan, same, filter grade B, then refrigerated dryer. So filter grade, so 38 Fahrenheit. So ito, mataas yung temperature, so tama na yung refrigerated na. Next shot, sandblast, dust collectors, di ba? Sawmill, lumber yards, natural gas, low pressure air gas. So, andito yun, filter grade A, single tower, delicacy dryer. So, 20 to 25 Fahrenheit na. Mataas. So, okay lang yan. So, bulk contaminant removal. So, point of use, ito na yun. Yan na yun. So, walang problema. Instrumentation, available. Food, beverage, clean room, critical instrumentation, low molding. So, not available yan. Hindi not applicable. Not available pa yung data. Check nyo lang. So, ngayon, ito. That is regenerative dryer. Heatless. Ito yung mga tinatawag na desiccant. Okay? Check na. Dito. So, compressed air dryer. Meron tayong refrigerated compressed air dryer. Refrigerated compressed air dryer utilize a mechanical refrigeration system to cool the compressed air and condense water and hydrocarbon vapor. Most refrigerated air dryer cools the compressed air to a temperature of approximately 35 Fahrenheit to 50 Fahrenheit, 1.6 C to 10 C, which results in a pressure dew point range of 33 Fahrenheit to 39 Fahrenheit. Okay? This range permits the pressure dew point to fall within limits that are achievable with common refrigeration system controls. The pressure dew point range is also the lowest achievable with the refrigerated design since the condensate will begin to freeze at 32 Fahrenheit. Refrigerated air dryers are available in two basic configurations, the non-cycling and the cycling. Ito yung mga refrigerated air dryer. kayong bibili basta-basta ng hindi nyo alam ang type. So, non-cycling, ito, compressed air dryer cools the compressed air in an air to refrigerant heat exchanger evaporator. So, ito. The one compressed air flows into one side of the refrigerator while low pressure liquid refrigerant, ito yung is metered in another side of the evaporator system refrigeration. The heat from the compressed air boils the refrigerant, thereby reducing the temperature of the compressed air. Operation of the refrigeration compressor is continuous or non-cycling. This is continuous. Therefore, require a combination of control valves to regulate refrigerant flow as the heat load from the compressed air changes. Cycling compressed air dryer cools the compressed air to an intermediate heat exchanger medium. So, dalawa siyang naka-close loop. Ito may medium siya. The intermediate can be sand, metal, or fluid. Two heat exchanger, a compressed air chiller, and refrigerant evaporator are fitted in second tank, which is filled with thermal conducting fluid, usually water, with polypropylene glycol added as a safeguard to prevent freezing and corrosion. The refrigeration system removes heat from the water glycol liquid. The chilled fluid removes heat from the compressed air. There's a storage and cycling. Since the refrigeration system is used to only cool the fluid, refrigeration compressor is cycled off once the fluid temperature is chilled to the required point. The compressor will cycle on only when the fluid temperature rises to its upper limit. The cycling of the refrigeration compressor results in significant energy savings on most compressed air systems. An average cycling compressed air dryer provides energy savings of 50% when compared to equally sized non-cycling design. Okay? Dalawang type ng refrigerated air dryer. Both non-cycling and cycling refrigerated air dryers are available from 5 ECFM to sizes in excess of 20,000 ECFM. When choosing between a cycling and non-cycling compressed air, you have to weigh the larger investment in cycling compressed air dryer versus potential utility savings. In general, a cycling compressed air dryer will pay back on application with inlet flows over 200 ECFM. All and above, 200 and above, suggestion is the cycling. However, this depends on how your plant consumes compressed air. If your plant has peaks and valleys in its compressed air demand, you will generally save money with a cycling compressed air dryer because the compressed air dryer will shut off during low demand times. Now, manufacturers rate their compressed air dryer in accordance with the recommended standard CAGI, Compressed Air Gas Institute. Standard number ADF 100 for 33 to 39 Fahrenheit pressure dew point. This is based on 100 PSI gauge inlet air pressure, 100 Fahrenheit or 37.C inlet air temperature, 85 Fahrenheit cooling water temperature, water-cooled units, and 100 Fahrenheit ambient air temperature for air-cooled units. Dalawa, water-cooled and air-cooled. The maximum airside pressure now allowed is 5 PSI. So good installation practice for refrigerated compressor dryer include minimize inlet air temperature, highest air pressure possible, lowest year-round ambient air temperature available. Now, to select a refrigerated compressor dryer, calculate a corrected flow, CFM. The example shows how to perform the calculation. For example, ito yung condition mo, system conditions, and the correction factors. Inlet air, 150 psi gauge. Babasahin ko lang yung emissions. Inlet air temperature, 120 Fahrenheit. The ambient is 110. It is base ambient temperature. Bakit master S? It is a best practice to use 100 Fahrenheit or higher for the ambient temperature to avoid accidentally undersizing a compressed air barrier. Okay? And the double asterisk, correction factor are standard. See tables below or next slide, correction factor for other temperatures. So this is the correction factor for this temperature, 1.51, and this is 0.86, is 1.16. Bakit? Ano ka kasi ang standard mo is 100. So, dito, air-cooled tayo. 100. So, this is 1.16. Kasi 110 ka. So, dito naman, 100 PSI gauge kasi siya. So, factor mo is 0.16. Kaya nag-150. 120 inlet air temperature, 120 Fahrenheit. So, ang 1.0 mo is 100. So, ang factor naman dito 1.51. Okay. Multiply correction factors by compressor flow, ECFM for corrected ECM, for the corrected ECM. So 0.86 times 1.51 times 1.16 times 500 ECFM or 14 cubic feet per minute. So ito lang basahin ko yung emissions will become 750 is CFM. So itong 500, ito yung required mo. So mag-select ka ng equipment based dun sa rating. Ano factor rating mo kasi merong basehan yun. So refrigerated compressed air dryer unrated and flow is FM. So round the corrected flow up to choose a compressed air dryer. So pumili ka doon ng above dito sa 753 ECFM sa catalog niya. Okay? So itong application na to, itong calculation na is papunta doon sa equipment. Meron namang method nito na galing sa equipment, papunta doon sa required CFM mo. So that is reverse selection. Okay? Kung tayo sa project niya, nakikita niyo yan. So ito kasi sa lecture, papunta ka na sa equipment. Calculate ka muna tapos hanapin mo din sa pressure. So ito yung mga correction factor at a certain pressure. Inlet air pressure, nakita mo yung 100 is 1.0 which is 7 bar. Inlet air temperature 100 so 1.0 and the rest iba. Ambient air temperature 100, this is 1.0 there. Ano na kayo niyan? Mga factor. Now to select a dryer based on pressure drop and rated flow, refer to figure 6, entering with actual pressure of the dryer inlet. So pressure loss to refrigerated air dryer, PSI times 6.9 is kilopascal. Dito yung average percentage pressure drop, PSI gauge. So kung ang pressure mo sa dryer is 100, dito 150, ako natin 150, di ba? Inlet air. So ito yung pressure drop niya. So 100, 125, ito 80% yung capacity, 100% ito. Makuha mo yung pressure drop. 5 PSI maximum. Kung mag-design ka sa 5 PSI, sabi kasi dito, yung maximum airside pressure drop allowed is 5 PSI. So 5 PSI ka sa 125. Pasok pa rin. 150, you have only 3. Next is the desiccant air dryer. Air dryer, air dryer utilize chemical beads called the desiccant to absorb water vapor from compressed air. 3 different types of desiccant are commonly used. Ang picture sa ito, ang loob niyan, yung mga desiccant, ay makita picture na tanggal na. Meron ng mga desiccant pero silica gel, which is an amorphous form of silica with very good water vapor absorbing capacity. Silica gel provides 40 Fahrenheit to -85 pressure dew point performance. A high efficiency coalescing pre-filter is required to prevent damage due to liquid water and oil slugging. Moisture resistant silica gel is also available but with less capacity. Next type is the activated alumina. A porous form of aluminum oxide with silicon dioxide. Activated alumina also has a very good water vapor absorbing capacity and will provide 40 Fahrenheit or -40 C. Actually, this is -40. -40 Fahrenheit. So, ayan. -40. Activated alumina provides good resistance to liquid water and is the preferred desiccant for heatless air dryer. However, high efficiency coalescing pre-filter is required. Yan, note. Molecular sieve. So, type ng desiccant. A porous form of zeolite of specialized desiccant formulated to remove specific vapor or gas molecules. So, kaya mga bibili mo air dryer, tingnan mo yung laman para may compare mo siya. Okay? They have excellent water vapor absorbing capacity with low relative humidity inlet and will provide pressure dew point of -100 Fahrenheit or lower. Molecular shield is easily damaged when slugged with liquid water or oil. Therefore, a high efficiency coalescing pre-filter is an absolute must. Next type is the okay. Silica gel or activated alumina is the preferred desiccant for compressed air dryer. Molecular shield is usually only used in combination with silica or activated alumina as a polishing bed. Desiccant air dryer are usually configured with 2 pressure vessels, filled with desiccant, switching valve to direct the compressed airflow, and controls for proper switching of the desiccant air dryer vessel. Single tower versions are also available. Basic operations ito yun. Of desiccant air dryer consists of 1 drying cycle and 1 regeneration cycle. Regeneration, yung ibabalik mo yung heat. Commonly referred to as NEMA cycle. For example, a 10-minute NEMA cycle consists of 5-minute drying cycle and 5-minute regenerating cycle. Generation cycle. This cycle is continuously repeated. During the drying cycle, compressed air at full pressure flows through one desiccant vessel. As the air flows through the desiccant bed, microscopic pores on the surface of desiccant bed strips the water, drying, vapor, and hydrocarbon molecules from the air, thereby reducing the relative humidity of the air dryer. Now, the relative humidity of the dryer is equivalent to a pressure dew point of -40 or lower. Since this stripping action by desiccant bed is a result of chemical reaction, it produces a small amount of heat called the heat of absorption. Kaya paglabas ng compressor mo, mainit. The heat produced is minimal and increases the outer temperature only slightly. During the regeneration cycle, the switching valve isolates the moisture-saturated desiccant vessel. This offline vessel is depressurized and the desiccant regeneration process begins. Following regeneration, the vessel repressurized with compressed air is again ready for the next drying cycle. Desiccant air dryer are available in 2 basic designs, the heatless and heated. Since the drying cycle on all desiccant air dryer is similar, the difference between The difference between heatless and heated design is found in the regeneration method. So a wide range of desiccant air dryers are available. There are two main categories of desiccant air dryer, heated and heatless. A general rule of thumb is applications below 200 SFM work best with heatless, and applications above 200 SFM work best with heated. Selecting a heatless desiccant air dryer. So advantages of heatless desiccant air dryer are they do not require additional utilities to regenerate the desiccant, siyempre walang heat, long desiccant life, and a dependable design. Desiccant is activated by taking approximately 15% of the compressed air and channeling it through the regenerator. So mainit pa yun. Ang disadvantage of heatless desiccant air dryer is that they consume 15% of pure compressed air. Kasi wala kang kuryente. To select a heatless desiccant dryer, obtain the inlet temperature, inlet flow, and inlet pressure. The maximum operating temperature of most heatless desiccant air dryer is 120 Fahrenheit. To calculate a corrected flow, multiply your inlet flow by pressure correction factor. So the inlet flow is FF, the correction factor is the corrected flow. For example, inlet temperature is 105 Fahrenheit, that is within 120 Fahrenheit maximum. Inlet flow is 325 SFM. Inlet pressure is 120 PSI gauge as a correction factor of 1.08. So therefore, 325 times 1.08 is 351. So doon yung binabasa ko hindi minumultiply yung 9.1 sa 9.53. That is yung equivalent cubic meter per minute lang. So the corrected flow is 351 SFM or 9.81 cubic meter per minute. So ito ang magiging CFM mo sa pag-select. So heatless compressed air dryer pressure correction factor. Dito pinuha yan. At 100 PSI, this is 1. The rest, wala. Now, for the heated desiccant air dryer, a heated desiccant air dryer regenerates by heating the desiccant either directly or indirectly. Heated desiccant air dryer have longer Pneumatic cycle and work well in large ECFM application. Heated desiccant air dryer are more complicated devices and require more maintenance than heatless desiccant air dryer. Constant heating and cooling of desiccant shortens desiccant life, requiring more frequent replacement. Some heated desiccant air dryer designs do not use compressed air to regenerate the tower, therefore conserving compressed air. Manufacturers rate desiccant air dryer capacity in accordance with recommended standard NFPA T327.2.3 M-81 or ANSI na B9345. Natin yun. This rating is based on 100 PSI gauge, 7 bar inlet air pressure, 100 Fahrenheit or 30 HC, this is 37.7. Inlet air temperature, and 100 Fahrenheit ambient air temperature. The maximum air pressure drop allowed is 5 PSI. The standard pressure dew point performance is negative 40 Fahrenheit. Many standard motor can be modified to provide negative 100 Fahrenheit pressure dew point. So manufacturers recommend several methods to reduce desiccant air dryer dew point to negative 100 Fahrenheit. Include shorten the pneumocycle, increase the compressed air dryer size by 37% over the recommendation for negative 40. Yan. Okay. Change the desiccant volume mixture and extend the pneumocycle on heated compressed air dryer. So ito yung types of heated desiccant air dryer. Merong internally heated. Desiccant generation is accomplished by heating the desiccant with internal electric or steam heaters in purged air. Either atmospheric air or compressed air from the air stream is used as the purged air. Internally heated compressor dryer are commonly used for storage ranging from 200 to 2,400 PCFM. Next is the externally heated dryer. Externally heated compressed air dryer regenerate the wet tower by heating purged air from the compressed air line to T50 Fahrenheit or higher and channeling the hot air through the wet tower. The hot air pulls off the absorbed moisture, thus regenerating the desiccant. The purged air bent to atmosphere. Number 3, blower purge. Blower purge is a type of externally heated compressed air dryer. The blower purge takes atmospheric air in through the blower. The air is heated to T50 Fahrenheit and 500 Fahrenheit and channeled to the wet tower. The hot air drives the moisture of the desiccant. Number 4, heat of compression. A heat of compression desiccant heat air dryer use the heat generated by non-lubricated compressor during normal operation to dry the desiccant. Its design reduce utility cost. Heat from compressed air dryer has the lowest utility cost of all heated compressed air dryer. Selecting a heated desiccant air dryer. So to select a heated desiccant compressed air dryer, determine the inlet temperature, inlet flow, and inlet pressure. To calculate a corrected flow, multiply the inlet flow by the pressure correction factor. So inlet flow times pressure correction factor times the inlet temperature factor. So kasama pala. So guro na sulat dito. This is now the corrected flow. So for example, inlet flow is 800 ACFM. Inlet pressure is 130 psi gauge. Inlet temperature is 90 Fahrenheit, which is a correction factor of 0.91. Yung 130 psi gauge is 1.87 ang correction factor. So, assuming 800 ang inlet flow, 800 times 1.27 times 0.91 is 925 ACFM. So, this is 29.9 cubic feet per minute. So now the corrected flow is 925 ACFM. From the manufacturer selection, you would choose the process standard model that is rated with larger capacity. For example, 1000 ACFM, 18 desiccant air dryer. Wala ko pinapagita po ng brochure. Brochure yan, kunwari 1000 ACFM. Available. 900, 1000, sa 1000 na. So ito yung inlet pressure correction table. 100 is 1.0 PSI gauge. 100 PSI gauge is Fahrenheit is 1.0. Inlet temperature correction factor. Next type, yung pinaka-minor, the liquid dryer. Utilize an absorption type chemical desiccant to provide 20 to 25 Fahrenheit dew point suppression below the compressed air temperature entering the dryer. So the moisture in compressed air react with the absorbed material to produce a liquid effluent that is drained out of the dryer. This effluent must be disposed of in accordance with local regulation. The liquid dryers are typically used in applications such as sandblasting and logging. They are not recommended for industrial applications since the dried compressed air exiting the dryer may contain a small amount of effluent that may be corrosive to downstream equipment. To select a desiccant dryer, you need to know the system inlet flow and the pressure PSI. Using these two factors, select a desiccant dryer which is rated to handle pressure. So sa catalog, may makita kang pressure and the flow rate. So yun ang select. Next, how to size the air receiver. The air receiver must in general be sized according to the variation in consumption demand, the compressor size, and the modulation strategy. Okay. Kasi storage to. In general, it is possible to calculate the maximum consumption in the system by summarizing the demand of each consumer. To summarize, consumption must be multiplied by with a usage factor ranging from 0.1 to 1 depending on the system. In practice, it is common that the manufacturer use the standardized receiver for a specific compression model based on their know-how. For calculating the receiver, note that it is necessary to with a pressure band for the receiver to be effective. If the consumption process requires 100 psi gauge and the compressor is set to 100 psi gauge, there is no storage and no buffer. Okay. And any increased demand makes a pressure drop below 100 psi gauge until the compressor controls respond by increasing the volume compressed. If the compressor operates at 110 psi gauge, the difference between 110 and 100 psi gauge accounts for the air stored in the receiver. Parehas, wala receiver. Pero bubog naman ang compressor. If the demand increase, the pressure can drop 10 psi gauge before the minimum requirement is met. Note that in compressed air system, the pipe form also makes the purpose of buffered volume. Volume. Pipe. The receiver storage may be calculated using the formula P is equal to V times P1 minus P2 over QS P8, where V is the volume of the receiver tank, T time for the receiver to go from upper to lower limit sa magana needs. So QS is the free airflow, P sub A is atmospheric pressure, P sub 1 maximum tank pressure, P sub 2 minimum tank pressure. Meron namang available na to standardize. The table below indicates normal receiver volume at given consumption. This table is based on the side pressure in 140 psi gauge. Ibig sabihin 100 to 140. So airflow, kung compressor mo ito, size ng receiver mo ang dito. So base ito sa 140 compressor size. Kung 110 sa mag-iba. Kaya ang compressor mo is mas matakas na receiver. Schematic diagram. So ito yung compressor, ito filter, ang filter, tapos yung compressor yan. Tapos ito valve, ito cooler, then ito, then receiver, filter ng dryer, paglabas ng filter, may bypass yan kasi hindi nyo kailangan tayo. Yung similarity sila. This is now the end of the topic. Also review your air compressor basic equation. Okay? Continue sa inyo o hindi, send mo sa mga review. Kailangan niyo ito yung isang equation. The cooling power compressor. Thank you.